Boyle's law. Okay, Boyle's law states that at a constant temperature, the volume of a fixed mass of a gas is inversely proportional to its pressure. Okay, that means that when volume increase, the pressure will decrease. When volume decrease, the pressure will increase. Okay, so let's say if I double up the pressure, okay, the volume will decrease by half. Okay, so how this happen is that, okay, so let's say here, okay, I have a shrink and we have a volume inside it. Okay, so when I pull down, okay, the plunger, okay, the volume will decrease. Okay, the volume will decrease. So when the volume is decreased, okay, the pressure will increase. Okay, so how the pressure is increased is, we know that the pressure is created by the molecules of gas hitting the wall of the container. Okay, so as the volume decrease, okay, the space between the molecule become smaller. Okay, so when the space becomes smaller, okay, the molecule will strike the side of the container. Okay, so as it hit the wall of the container, the pressure will increase. So we can write it mathematically as PV equal to K. Okay, so K is the constant, P is the pressure, and V is the volume. Okay, when we have a condition where we have to compare between two situations, before and after, we can write it as P1V1 equal to P2V2. Okay, so P1V1 will be the condition before and P2V2 will be the condition after. Okay, we also can represent it graphically. Okay, if we plot P versus V, okay, we're going to get a hyperbolic curve. If P versus 1 over V, we're going to get a straight line. If PV versus V or PV versus P, we're going to get a straight line which is parallel to the x-axis. Okay, so remember that the Boyle's law is P1V1 equal to P2V2. Okay, so it is a inverse relationship, okay, between the pressure and volume. Okay, so as the pressure is high, the volume will be low. When the pressure is low, the volume will be high. Okay, so remember, the temperature and the number of molecules does not change. So here are some example of the real life application of Boyle's law. Okay, so let's see, okay, how the Boyle's law apply in a bicycle pump. Okay, so let's say, okay, we have a bicycle pump here. Okay, so when you push down the handle here, the volume of the air that trapped in the pump will reduce. Okay, so when it reduce, okay, the pressure will goes up. Okay, so as the pressure goes up, the air is forced into the tire. Okay, so let's see the example in breathing. Okay, so in breathing, okay, so when we breathe, okay, that the diaphragm will move downward. Okay, so when the diaphragm move downward, the volume inside our lung will increase. Okay, so as the volume increase, the pressure inside our lung will decrease. Okay, so the pressure inside our lung is less than the outside. Okay, so the air will rush in, okay, and flow towards the lower pressure in the lung. Okay, so as we breathe out, okay, the lung volume will decrease. The lung volume will decrease and the pressure in our lung will increase. Okay, so therefore the air will flow out, okay, from higher pressure to the lower pressure. Okay, so same goes with the application in shrink or when we in scuba diving. Okay, so we know that as we dive deeper, okay, the pressure will increase. Okay, so as the pressure increase, so this will affect the volume inside our body. Okay, now let's see the calculation with Boyle's law. Okay, a tank of nitrogen has a volume of 14 liter and a pressure of 760 millimeter of mercury. Find the volume of the nitrogen when its pressure is changed to 400 millimeter of mercury while the temperature is held constant. Okay, so first of all, okay, take out the information given in the question. Okay, so it will be easier for you to see what is given and what you need to find. Okay, so here we have, okay, the condition before and after. Okay, so before, given that the pressure is 760 and volume is 14 liter, and after we have the information for the pressure. Okay, so the question asks to find the volume, okay, the final volume. Okay, so we know that the formula for Boyle's law is P1 V1 equal to P2 V2. Okay, so just plug in, okay, into the equation. Okay, so we're going to get 26.6 liter. Okay, so if you get confused, okay, what will be the unit for the volume? Okay, so always write up the units. Okay, so we know that here we can cancel out the unit of the pressure. Okay, so what remains is the unit for the volume. Okay, so we know that the unit is in liter.